name's Chris Brophy. I'm the roundhouse foreman here at the Durango and Silverton Narrow Gauge Railroad. So on a coal burning locomotive, you hand scoop the coal from the tender, which follows the locomotive that has coal and water in it, and you scoop the coal out of there and shovel it through the air-operated fire doors into the firebox. Roughly 4 or 5 tons per trip, about a ton an hour on the way up and a ton coming home. Acquiring coal is becoming more and more difficult, and our source in Hesperus is great coal, but it's about the only coal that we've ever found that works really well for burning in our locomotives. And so converting them to burn oil allows us to have multiple sources of fuel and not to rely upon only just one source of fuel. We're converting the 480 and the 473 to burn oil and preparing those engines for the Silverton season, along with the 2 diesel locomotives we just got from the White Pass in Yukon, preparing them for service, one of which is done, and the other one of which we're beginning the process of getting it back in service with hopes of maybe a June or July operational date for those. The 473 we hope to have running probably in the next 3 weeks, and the 480 following right behind, maybe a week or 2 after that. Along with our fleet, we have the 18 visiting from California. That's an oil burning locomotive too, that's going to help us out with hauling trains until we have all of our power ready for the season. We have a fully functioning machine shop with like 6 lathes, 3 or 4 mills, some specialty equipment, and we're basically self-sustained here. We can build, manufacture, machine just about every part necessary to keep these locomotives running. Welders, machinists, pipe fitters, just about every trade you can imagine, we have those skill sets here on the property to keep every aspect of the engine running. So a coal burning locomotive has a lot more apparatus in the front of the locomotive boiler called the smoke box, which was designed to catch and dampen cinders as they were pulled through the tubes and then out the smokestack. With an oil burner, there are no cinders, so the front end is quite a bit simplified to where the smoke and heat travels out and then right up the smokestack. So we've had that process along with the firebox where we've taken the grates and the grate shakers out and installed fire brick and mortar to create the burning surface. And the front end was another area that had a lot of work done on it in changing how the draft mechanism works on the front end of the engine. You look down in there, you can see that little brass thing kind of all the way up front there?
Oh yeah.
That's the burner. That thing right there in the middle, that's the burner. And that just takes oil from the oil bunker back here and mixes it with steam and atomizes it into a mist and blows it in a throttle here in the Johnson bar. This here is your engine brakes and your train brakes here. So the boiler is filled with tubes. It's what's called a fire tube boiler. It's surrounded by water. That water is boiled and then is turned into steam. When you open the throttle in the cab of the locomotive, the steam then goes through the superheater header, through the dry pipe, through the superheater header, gets superheated to a roughly 600 degrees, and then admitted into the cylinders, which are connected, or which have the piston in it, which then drives the main rod connected to the main driver, and all the other drivers are connected via the connecting rods and drives the wheels.